All right, so we're going to go over chapter 11 now, which is engine fundamentals. All right, after this chapter, you'll be able to identify the major parts of a typical automotive engine, describe the four-stroke cycles, define common engine terms, explain the basic function of the major parts of an automotive engine, cite and demonstrate safe working practices related to engines. All right, engine operation. The engine is our source of power for the vehicle. Fuel is your energy source. The combustion chamber is the hollow area between the top of the piston and the bottom of the cylinder head where the fuel is burned. So the engine is one that turns chemical energy from burning fuels into mechanical energy, which is the turning wheels. Okay. Combustion produces heat. Heat causes expansion of gases in the engine. Expansion causes pressure. The piston, connecting rod, and crankshaft convert that pressure to motion. Motion drives the gears, chains, sprockets, and belts to help move the car and operate different systems. So the engine just doesn't move the vehicle. There's other operations it does as well. One of those things is, and it is used to turn the alternator, which is what charges the battery and runs the electrical system on the car. It also turns your air conditioner compressor so that it cools down the cabin of the car. So it has multiple functions in a vehicle. All right, piston travel. And distance the piston moves up or down. Crankshaft does limit this. Top dead center. This is the top of the piston travel. This is the top of the stroke. This is as high as the piston can get. And then bottom dead center is the very bottom, is the direct opposite. The distance or the travel between top dead center and bottom dead center is your piston stroke. So here's an example of that. So to the left here is your top dead center. So the piston's as high as it possibly can get. And then bottom dead center is the direct opposite. It's as low as it can get. So one stroke is from top dead center to bottom dead center. And then the other way, bottom dead center to top dead center is another stroke. All right, our four cycles. Most vehicles nowadays run on a four-stroke system or a four-cycle engine. We've tried in the past to use two strokes for vehicles, but it does not work. The oiling system doesn't work for a normal motor vehicle. Dirt bikes and stuff, it works fine for those. Before cars, it just didn't work right, and they're a little bit more heavy on pollution as well. So four strokes is what we need to learn. So if we look here, our first stroke is called our intake stroke. Our camshaft will turn. You see how it has a egg shape to it that pushes down on this valve, which opens up. A small amount of fuel is sprayed in, and air is right behind it. So as the piston travels down, this is sealed up in the cylinder. As it travels down, this creates a vacuum right here. So that draws air in, and it draws the fuel in. This air and fuel is mixing as it comes in to the cylinder here. The piston is moving down. The connecting rod is rotating here. All right. Once it gets past that, you can see the camshaft turns, closes the valve. As the crankshaft comes back up, it pushes the piston up. So all that fuel and air we just drew into it, now we're going to compress it to a very, very tiny area. So think of a 2-liter engine in a Honda Civic or something, a 2-liter bottle, that amount of air, we're now going to compress into a very tight, small chamber that is your compression or your combustion chamber. So as this moves up, it's compressing that air and fuel charge right there. At a very specific time, the spark plug will create a spark. That's why it's named the spark plug. That spark will ignite this fuel and air and make a little small explosion. That explosion, that heat is going to drive that piston down. That air and fuel mixture now, as it's exploding, is expanding and is going to drive this piston down. This is our power stroke. I forgot to mention, this is our compression stroke, by the way. So as we're compressing things, that's our compression stroke. And then when the spark ignites, this is our power stroke, our combustion stroke. So now the piston is going to drive down, which is spinning this crankshaft. Once it gets pulled around, the camshaft is going to rotate around and open our exhaust valve. And so now our piston is going to push the burnt gas, all the exhaust out, which will be connected to our manifolds and our exhaust system and exit out the rear of the vehicle. So if you count it, intake is our first stroke, second is our compression, power stroke is our third, and our exhaust stroke is the fourth. So as you can see, it's going to come up, and when it gets to the maximum height and that exhaust valve closes, the intake valve is going to open as the piston comes back down, and it's going to draw more air and fuel in, and we start the cycle back over again. So it goes over and over again. It's a never-ending cycle until we stop it or something happens. All right, engine bottom end. It's our block, our crankshaft, connecting rods, pistons, and our related components to those. All right, our engine block, it's also known as a cylinder block. This is the main body of the engine. Cylinders are large round holes machined through the block. The piston fits into the cylinders. The deck, or the deck surface, is the top of the block surrounding the cylinder. The cylinder head will bolt to the deck of the block there. It bolts to the deck. Right. Our water jackets. So with combustion, those explosions cause tremendous amounts of heat. We can be upwards of 6,000 degrees Fahrenheit. So we have to keep them cool. Inside the engine block, between the outside and the cylinders, there's a little bit of a hollow space. This is called our water jackets. This allows coolant to flow through that to cool the cylinder block and the pistons down some. Right? We have core plugs or freeze plugs in the cylinder block. So if for whatever reason that coolant freezes, water, when you freeze it, it expands, right? We learned that in science. Well, to keep that expansion from damaging the engine and cracking the cylinders or the block, we have these plugs in the engine that will be pushed out if that happens. For whatever reason, if something wrong happened and our coolant froze, that way it can relieve that pressure and save the block. And we can replace those freeze plugs. They're a little bit better than replacing an entire engine. Main bearing bores is holes. These are holes machined in the bottom of the block to hold the crankshaft. This contains removable bearing inserts. Main caps is bolts to the bottom of the block. Main caps bolt to the bottom of the block. This holds the crankshaft and those main bearing inserts into place. Our engine bed plate. Some engines have this, some don't. The engine bed plate is like the main caps, but they're all joined together as one giant block. So it'll have multiple bolts still to bolt it all down, but it'll be one, they'll be all tied together. This creates a stronger block, a little bit more hold down force. This is for performance vehicles, and trucks normally use this. Our crankcase is the lower portion of our block. This is where the crankshaft rotates inside of. This is the area that your oil pan, your inside of your oil pan is and everything. Our crankshaft harnesses forces produced by pistons, changes up and down motion, and a rotary motion. Fits in the bottom of the engine block. So think of a bicycle. Your pedals mount to what's called cranks. This is a crankshaft. It's the same thing. So the up and down motion as you pedal around, is going to turn those cranks, and it's going to turn that up and down motion into rotary motion. So it's going to spin and go out the back of the engine where it goes to our transmission and into our wheels. So, main journals, these are precisely polished, fits into the main bearings. Rod journals, these are offset from the main journals. The connecting rods bolt to the journals and revolves around the center line. All right. Counterweights. So counterweights of connecting rods, pistons, rings, and rod journal offsets. This prevents vibrations. As the pistons move up and down, it has to stop at a certain point and change direction. That creates a force of motion going up or down. We have to counteract that momentum and everything to create, get rid of vibrations and stuff. So the engine isn't rocking and moving all around. So on the opposite end of where our connecting rods are going to bolt to, we have a weight. So we have the same amount of weight going back and forth to counteract each other, to get rid of those vibrations. Snout, it sticks out of the end of the block. This provides a means to, this provides mounts for camshaft drive mechanisms and your front dampener, and your fan belt pulleys, things like that. So we can drive those accessories. Our flange is on the back of the crankshaft. This is where the flywheel bolts to. Center of the flange has a pilot hole or bushing. This supports the transmission shaft. Our rod journals are arranged so always at least one cylinder is on power stroke. So as one piston is hitting a power stroke and being pushed down, another one's going up to compress, and then that one will fire while that one is on its exhaust stroke, so that every cylinder is on a power stroke. This creates a nice smooth engine, makes it run very well. Engine main bearings fit between the block and main bores and crankshaft main journals. Consists of two removable inserts. Upper main bearing fits into the cylinder block. Lower main bearing fits into the main caps and bearings, or main plate. I keep messing up talking. I cannot talk. Fits into the main caps or the bed plate, depending on what you have. So this bearing isn't like a normal bearing you see. It's just a metal insert. It's designed so if there's wear, we can remove the insert and replace it. Otherwise, the engine would have to be replaced if we didn't do that. The way it works is it rides on a film of oil that separates the main journal of the crankshaft and the main bearings. So that oil film separates the two. So it rides on that oil, not on the actual bearing itself. That's why motor oil is so important. That's why the viscosity is so important. That thickness of oil is all dependent on how much of a gap there is between the crankshaft and that main bearing. So if it's a bigger gap, we need a thicker oil. If it's a smaller gap, we need a thinner oil. Otherwise, that oil isn't going to create a good film, and that crankshaft's going to hit that bearing and cause damage and premature wear. Oil holes and grooves allow oil to flow through the block, main bearing, and crankshaft. The main thrust bearing, this limits the distance the crankshaft can slide in the block. Flanges limit in play. So this the thrust bearing is so the crankshaft can't move forward and back. This is very important in a manual transmission car, because when you push the clutch in, it wants to push the crankshaft forward. So your main thrust bearings are very important in a manual transmission car. They usually are what wears out after a while. Main bearing clearance is the space between the crankshaft main journal and the main bearing insert. This allows oil, like I said before, to enter the journal and to rotate without rubbing. Crankshaft oil seals keep the oil from leaking from the front and rear of the engine. Rear oil seal is on the rear, and the front seal is on the front on the snout. Flywheel is a large metal disc mounted on the rear of the crankshaft, connects crankshaft and transmission, or crankshaft to transmission, or the transaxle, right? Very heavy is subjective term, depends on the engine, and depends on how strong you are when you think about it. Very heavy for some people might not be as heavy for others. But it's heavy. This helps smooth the engine operation. So that weight of the flywheel keeps momentum going and keeps the engine rotating at a certain RPM so the engine runs very smoothly. Contains a large ring gear, so the very end of it, the outside of it has teeth on it. So the starter is another gear that will turn those teeth and turn the engine to get it started, to crank up the engine. The picture of your connecting rods. Okay. Fastens the piston to the crankshaft, connects the piston to the crankshaft. That's why it's called a connecting rod. It's a rod that connects the two. Transfers the piston motion. Connecting rod bearings ride on the crankshaft rod journal. Fit between the connecting rod and the crankshaft. And the crankshaft. So you can see here, these are your rod bearings. They're the same as your main bearings, just a different size, different thicknesses, or whatever. But it's two little metal inserts. You also have a bushing or a bearing up here. You have connecting rod, small end here, and your large end down here. See all the parts there. But this overall is your connecting rod. Piston transfers the pressure of the combustion to the connecting rod and crankshaft. Piston head is the top of the piston. Piston ring grooves are slots cut in the piston or piston rings. The piston oil holes allow the oil to flow through the piston onto the cylinder wall and also back down so it can fall into the back into the oil pan. Piston ring lands are the area above and between the ring grooves. Piston skirt is the side of the piston below the last ring. Piston boss is the reinforced area around the piston pin hole. The piston pin hole is the hole in the piston boss or the piston pin. So we can see here the boss is right here. You can see how it's reinforced. Our piston pin here. All right, we need this to swing. So the bottom of the crankshaft and the bottom of the connecting rod is going to go in a large circular motion, while the top is not going to move. So we need it to swing. So the piston pin allows for this. It's also called a wrist pin because you think of this as your piston, this is your connecting rod, and your wrist will allow your elbow on the crankshaft to move like it has to. So the wrist pin allows it to move around. All right, piston rings seal the space between the piston and cylinder wall, along with oil. Oil helps seal it as well. Most pistons use 3 rings. So a gasoline engine will use 3 rings. Your compression ring, your secondary compression ring, and your oil ring assembly. Your oil ring assembly is a set of 3. But it's 1 ring. So your scrapers and your oil rail right here. And I mean, gas engine has 3. 4-stroke engine has 3. If it's a 2-stroke engine, it only has the compression rings. The way those work, they don't have oil rings. But 4-stroke engine is what we're learning, has 3 rings. Compression rings prevent combustion pressure from leaking into the engine crankcase. This is known as blow-by when that happens. Oil ring prevents engine oil from entering the combustion chamber. So as the oil rings come down, the 2 on the top are called your scrapers or your oil rails. Those will scrape the oil off, or your scrapers, you'll scrape it off. Your oil rail is a zigzag pattern, so it has holes in it so that the oil can go in there, and it goes through oil holes in the piston and falls down into the crankcase. Your ring gap is the split or space between the ends of the piston. This is so we can open the piston ring up to get it on the piston when we install it. The engine top end, this controls the airflow and sometimes fuel into the engine cylinders, controls flow of the exhaust out of the engine. Your cylinder head bolts to the deck of the cylinder block and encloses the top of the cylinders. Your intake and exhaust ports are cast into the cylinder head. They're made into the cylinder head. Your intake port routes air. Your exhaust port routes burnt gases out of the engine. Bolts to deck cylinder head. Blah, blah, blah. Okay. Valve guides are small holes machined through the cylinder head for the valves. These guide the valves in the correct path. Valve seals, or valve seats, sorry, getting ahead of myself. Valve seats are round machined surfaces in the combustion chamber port openings, so the valve can seal against the head. That was supposed to be on that slide. Okay, valve train. This is the valves and the operating parts. Your camshaft, lifters, push rods, rocker arms, valves, valve seals, valve spring assemblies. All of this stuff is your valve train right here in this picture. Cam lobe spins around, pushes against this lifter, which pushes against the push rod, which pushes against the rocker arm, which rocks down and opens the valve right here. And then when it turns, the valve spring will close everything back up. Every engine doesn't have this. Sometimes the camshaft might be directly under the rocker arm, so it doesn't have a lifter or push rod. Sometimes the camshaft might be on top of the valve spring, and so we don't even need the rocker arm or anything. Sometimes the camshaft might be on top of a rocker arm to push the rocker arm down, and the rocker arm has a pivot on the back to be pushed down while the camshaft runs top. So it depends on the manufacturer how they want it made. Our camshaft is located in engine block or the cylinder head. It contains cam lobes, drive gears, eccentrics, journals, thrust plates. So camshaft, this long piece here, has egg-shaped cam lobes, and cam journals is what is going to ride in your block. It's going to rotate on that. Valve lifter, also known as a tappet, rides on cam lobes and transfers the motion to the valve train. Your push rod transfers the motion between the lifter and rocker arms. The rocker arm transmits motion to the valves, and it rocks back and forth, opening and closing the valves. It's called a rocker arm because it rocks back and forth. Look behind me. These are rocker arms here and your valve spring right here. This is your cylinder head. These are performance racing stuff, so they look all nice and pretty, things like that. Valve train, valves open and close ports in the cylinder head. Intake valves control the flow and fuel mixture. They're larger than the exhaust valve. Exhaust valves control the flow of exhaust gases out of the cylinder. So our valves look like this. Our parts are the valve head down here. Our margin, which is a space right here. It's a flat space, just kind of the thickness right there. Our face, which is this part right here, this little angled spot right here where the cursor is. That's what our valve seat's going to seal against. Our steel, this is the long shank there. Our keeper grooves, this is for our valve keepers. This locks the valve to the spring. Our valve steel tip. Right. Valve seals prevent oil from knowing this. So if we didn't have a seal up here, Oil in the cylinder head will leak down the valve stem and into the combustion chamber, which causes smoke, and it will cause you to burn oil and lose oil. So we have a seal to prevent that. Valve spring assembly is used to close the valves. Consists of a valve spring, retainer, two keepers, and our shield. Right, you can see in our keepers, it's kind of angled. Our valve springs want to push against the angle to push it in really tight against the valves. And you can see here it has a ledge that is going to lock into the keeper grooves of the valve so it can't go anywhere. So it's going to lift the valve up. Intake manifold bolts each side of the cylinder heads, contains runners or passengers to each cylinder head intake port. Air and fuel is routed through the runners. Fuel injectors, only air passes through the runners. The injectors are injected into the head port. Fuel injectors injectors extend directly into the combustion chamber. Exhaust manifold fastens over the exhaust ports, carries burnt gases into the exhaust system. Right here in this picture, this is our exhaust manifold, these little tubes coming out. They don't always look like that. This is a performance engine behind me. Those are also known as headers. But anyway, they can be made of heavy cast iron, aluminum, or stainless steel tubing. These are what stainless steel tubing is going to look like. Our valve covers, which are also known as rocker covers, are thin metal or plastic lids over the top of the cylinder heads. This covers up the valves. That's why it's called a valve cover. So interesting. It keeps the valve train oil from spraying or leaking out over the engine. So everything put together looks like this. Intake comes in, goes through here, is compressed, ignites, push out the exhaust on the other side and out the back of the car. Engine front end. It's all the parts attached to the front of the engine. Your camshaft drive, your front seal, front cover, your oil seal, your crank dampener, all of that. Additional parts can be your oil pump, your water pump, chain or belt tensioners, auxiliary drive or sprockets, and your engine sensors. So you can have a lot of stuff on the front of your engine. You see here is a picture of everything, your crankshaft, snout sticks out the front, gears, all of that stuff. Right, crankshaft drive. So or camshaft drive, I mean, it's needed to turn the camshaft at 1/2 the engine speed. So for every RPM, the camshaft is going to turn only half. So the engine has to go through 2 RPMs for the camshaft to turn 1. The reason being is the every engine has 2 top dead centers. You have top dead center at compression stroke and a top dead center at exhaust stroke. Only one of those strokes needs the valve open. So it turns at 1/2 the speed so it can open them at the correct timing. If they don't open at the correct timing, the engine won't run. And if it did run, it would run absolutely terrible, as well as the valves can actually contact the pistons on most engines. So to do all of that, we have timing belts, timing gears, timing chains, times the camshaft with the crankshaft. So there's different things where we can have chains that run the two, or we can have a belt that runs the two together. Some engines out there, Audi, Volkswagens, if you ever work on some old Ferraris by chance, I think the old Enzos are like this. They had a series of gears that looked like a bunch of clockwork to time it all together as well, but that's not very common. Front cover bolts over the crankshaft snout, holds the oil seal that seals the front of the crankshaft, also called the timing cover. So another picture here showing you what I was just explaining. So covers all of this up. Sometimes it will have a seal. Sorry about moving it. It will have a seal to prevent any oil leakage. A crankshaft dampener. This is an important part people don't realize. It's a heavy wheel and the crankshaft snout. Mounted in rubber, this helps prevent vibration and damage. It's called a harmonic balancer or a vibration dampener. So the crankshaft pulley has rubber in it to absorb vibrations of the crankshaft. If the crankshaft has vibrations vibrating all around, it's going to vibrate on those main bearings and stuff and cause them to wear out and cause damage. People like to get a solid one because it's chrome and shiny and pretty and put on their engine, and then they're confused why their engine started knocking after a month of doing that, and that's because of the vibration damaged the bearings. So it's very important to have this up there to get rid of those harmonic vibrations. Y'all have any questions, be sure to let me know and I will answer them for you. And please, I talk about this all the time, and I will show you up here as well about my playlist. So, hang on a second, and I will show y'all just a second. All right, you go on Canvas, click your modules. Right here it says playlist. Click that and click that link there, and it comes up with all these playlists. Whoa. And if you look, they're all separated. So we can go over here, engine fundamentals, show animations of how engines work. Show you the difference between a 2-stroke and a 4-stroke, because I did mention that. And go back. There's some other ones down here. Where are they? Auto basics here. Click on that one. How a car works. How to change engine oil. Every engine layout. So diesel engines, difference between diesel engines. We also have transparent engines, so you can actually see how it works on the insides. Go back. We have some engine components, so we can learn the inside of engines. This guy, you can see the engine, these race engines being torn apart and put back together and stuff like that. It's really cool stuff. Lots of good information in there. So be sure to go on YouTube to my playlist and check out all the playlists to make sure that you get the visual representations you need for stuff. Make sure you understand this stuff very well. All right. So I'll be making another video shortly for our next chapter once we go through our next chapter. All right.